Okay, we're going to add this to our notes. This is example 6, right? Yeah, think so. I stopped labeling the numbers in the video and then I started again. And okay, so you're going to do 1 over 6 minus 1 over 3x equals 1 over 3. And in the beginning of the problem, we are subtracting fractions. And what do we always have to do if we're adding or subtracting fractions? Starts with a C. Common denominator. So what would the common denominator be? We have a 6, a 3, and a 3. 6. So of the numbers, you need the bigger number that everything would go into. And then one of them has an x. The other two don't, but one of them has an x, so we definitely need an x. All right, so what would we do to the first fraction? Yeah, so times x times x. What would we do to the second fraction? 2. It would multiply by 2 because it's a 3 right now. So 2, 2. What about the 3 on the end? 2x. Okay, so at this point, I have x over 6x minus 2 over 6x equals 2x over 6x. And at that point, when I can see that all my denominators are identical, what do I do? I think there's pencils back there. What do I do once I see all the denominators are the same? I get rid of them. I don't need them anymore. Okay, so the equation I have is x minus 2 equals 2x. So minus x, negative 2 equals x, and we're done. And what do we always want to double check? It starts with an E. Starts with an EX. Excluded. We want to check for the excluded value to make sure the answer that we got is not the excluded value. So what would the excluded value be of a denominator that is 6x? No? No? It's a monomial, right? It's just one thing. And the excluded value, whenever you just have the one thing, is always 0. Yep, can't have 0. And since our answer wasn't 0, we're totally fine. So that's a good answer. Okay, well, let's try another one. One over 3x to the third equals 1 over 3x minus 5 over x squared. So if we look for our common denominator, so we have a cubed 1 and 2, we need a third. So we can't make the denominators involve any less information than they have, but we can make them bigger. We can have them involve more information. So x to the third was the biggest exponent, so that means that's the one we have to have. Okay, so does the first fraction need anything? No, it's got the whole common denominator. What does the second fraction need? Yeah, x squared, x squared. What does the third fraction need? It needs a 3 and an x. Okay, so we have 1 over 3x cubed equals x squared over 3x cubed minus 15x over 3x cubed. You guys, I'm sorry. I wrote down the wrong part for the last. Well, we can try to. We'll go ahead and solve this one. This one's going to be harder to solve because I wrote 2 parts of one problem and 1 part of another problem. So it's not. It's not the. I'll just go ahead and show you. I wrote down these 2 and then this one. Oh, you can't see that. I wrote down these 2 and then that one instead of that one. So these are not going to be the answers. They're going to be messy. Sorry. Yeah, I was looking at that and I was like, that's not going to work out well. What did I do? I wrote down the wrong part. We still cross out the bottom. 1 equals x squared minus 15x. And then you're right, we're going to move the 1 over. Yeah, how did you know that we needed to set it equal to 0? Yeah, it's... Yeah. Yeah. Now, can you tell how I figured out that I wrote something down wrong? How did I figure out I wrote, like, nothing multiplies to 1 and adds 15? So this would be a quadratic formula problem, and those answers, like, I think we might get imaginary answers. We're going to go ahead and leave this one, because I accidentally wrote it down wrong. That was my bad. All right, so we'll go ahead and write quadratic formula, but we're not going to do it, because I'm pretty sure the answers are going to be imaginary. Okay. Actually, they're not. They're just going to be decimals. We'll go ahead and do it. If you guys get ones like this, they're going to be factorable. The only reason this one's not is because I messed up. Okay. Do you guys remember the quadratic formula? Okay, so in this problem, we have a is 1, that's the number in front of the x squared. B is negative 15, that's the number in the middle, and then C is negative 1. So if we start doing the quadratic formula, we get x equals negative b. If b is negative 15, then what's negative b? 15. So 15 plus minus square root b squared times 1 times negative 1 divided by 2a. Okay, and then what part do we type into our calculator? The part on the inside for now. So we're going to do negative 15 squared minus 4 times 1 times negative 1. And we're taking the square root of 229. Charlie, why do I hear your voice? Yo, Charlie, why do I hear your voice when you're watching a video? Hey, Charlie, come here. Should I be able to hear your voice when you're taking your notes? No. No, go out there and be silent. Tell other people to be silent too. Finish your notes. Okay. All right, what do I do now? Perfect. So I'm going to go ahead and do alpha y equals so I can plug it in all at once. How are you guys going to get the answer? Well, this is awkward. Well, I'm going to get the answer. I don't know what you guys are going to do. Say it again?
I got 15 points.
Yep, I did too.
I got negative 20. Oh, shoot.
Look at you guys getting your calculators out. You did not. You were just typing back and forth. Yep. Well, I wonder what the answer was. I'm not telling you guys, you cheaters, trying to steal it from me. Oh, 229, not 239. There you go. Yeah, because your answer was close, but not quite. All right, here's the next one. Miss Rice, are you not going to do it for real? Exactly. How's that not fair? You all have calculators. It's totally fair. Okay. This example I'm going to write down correctly, okay? So this one is not going to be as ridiculous as the other one. Okay. Also, on the assignment today, there are no problems that require the quadratic formula. None. So don't stress. There are problems that require factoring, but that's it. Okay. So what's the common denominator? N squared. Okay. Does the first fraction need anything? No. What about the second fraction? Yes. It needs an n. So n times that stuff. Okay. What about the third fraction? What does it need? An n times n times n. Okay. So our first fraction stays the same. What is our second fraction now that we multiplied the top? N squared minus n, okay, plus n over n squared. Oh, I forgot to write n squared here. So n times n is n squared on the bottom. So what can I do now? Yeah. Cross out the bottom. And then I have an equation I can combine like terms on. So n squared minus 4n minus 5 equals n squared minus n plus n. Because these cancel each other out, right? And then we have n squared minus 4n minus 5. The other n squared over? Like bring this one over to this side? Yeah. So when we see anything that has an n squared and an n, then it's like, oh yeah, that looks like a quadratic equation, so we should probably make it equal 0. So I minus n squared and I minus n squared. And when I did this on the right side, what did I get? 0. Okay. What happens over here? Those cancel out, right? Okay, so negative 4n minus 5 equals 0. And I don't really need to factor anymore. Why don't I need to factor anymore? Yeah, it's not a quadratic anymore, right? We got rid of the n squared. Okay, so what could I do to solve it now? That's still thinking factoring. I don't really have to do that, though, if I don't want to. You could plus 5. So if we do that, now we're getting it so our variable's on one side and our number is on the other side, which is a good option since we don't have to factor. And then divide by negative 4. So n equals negative 5/4. You could leave the negative on the bottom. You can stick it out in the front. You can move it to the top like I did. It doesn't matter. They're all the same. Yep. You'll see the assignment today. We're doing another color by number sheet. When I did the answers, I made them all fractions, not decimals. It's the one that you requested. Emina, yeah. All right. I want to do one with denominators that are a little different. All right, 6 over a minus 6 equals a plus 4 over 2a minus 12 plus 1 over 2a minus 12. So these denominators are different because they're not monomials anymore. It's not one term. They're binomials now, which means they're two terms. So what could we do with these two denominators to make sure we know what we're dealing with? We could factor them, and these are GCF factoring. So when we factor those, what do we get? Yeah, 2a minus 6, 2a minus 6. And then once we factor those, it makes our common denominator a lot easier to recognize. So for your common denominator, you definitely need the a minus 6 because all of them have that a minus 6. And then these two fractions have the 2 in the front, and so you definitely need to have the 2 in the front. So the second two fractions are what they need to be. The first fraction needs the 2, like Christian said. So we have 12, 2 times a minus 6, a plus 4, 2 times a minus 6, 1, 2 times a minus 6. And since the denominators were the same, we can just get rid of all of them. So we have 12 equals a plus 4 plus 1. Twelve equals a plus 5. 7 equals a. Okay. All right, and we forgot to do it on the last couple problems, but I am supposed to go back and look at this. Excluded values. A cannot equal positive 6, because this time it's a factor, so we do the opposite sign. Is that what I needed it to not be? So this answer is good. It's not 6. We needed it to not be 6, so we're okay. All right. Say it again.
The quadratic formula, what do you do with the excluded values?
If you look back, so number 7, here the excluded value, because it was a monomial on the bottom, so if you look at that denominator, that was 3x cubed. That's an excluded value of just 0. X cannot equal 0. So as long as your decimal answers didn't equal 0 exactly, you're fine. And they didn't. The decimal answers were something else. Yeah. So those were both good answers. Okay. Okay, let's do one more, and then I'll let you guys start working on the assignment. Are you guys feeling a little bit better about the process than you did when you just watched the video last night? Yeah. So last example, we're going to do 2 over r equals 1 over 4r squared plus 6r plus r minus 3 over 2r squared plus 3r. Mm-hmm. 2 and what else? 2r, okay, and then what's left over? 2r plus 3. Okay, how about when you factor this one? Take an r out, and then 2r plus 3. Okay, so our common denominator for sure needs the parenthesis 2r plus 3, right? What else does it need? It needs the r in the front, right? Because we have an r and an r and an r, and it needs a 2 because that one had a 2. Okay, so the middle fraction has it all. The first fraction only has the r. You need the 2 and the 2r plus 3. So I'm going to do 2 and 2r plus 3. It's so shiny until it dries. Okay, this one has an r and a 2r plus 3. What does it need? It needs a 2. So we need a 2 and a 2. Okay, so the first fraction, we said this was like a 4. 2 times 2 is 4. And so when I take that 4 and I distribute it, what do I get? 4 times 3, 12. Oh, you're good. 2r times 2r plus 3. equals 1. This one stayed the same, right? We didn't need anything. Plus, and then what do we get for this one? Okay. So 8r plus 12 equals 1 plus 2r minus 6. Mm-hmm. Okay.
-5, right?
Mhm.
And then just shift them over, get that R's on one side, and then
Okay.
R's on the other side.
Do you want to move the 2r over here, or do you want to take the 8r and move it over there? 2r? So minus 2r would give us 6r plus 12 equals -5. Then what do I do? If I add 5, what's going to happen on the 5 side? It's going to zero out, so I'm going to subtract the 12. Okay, so 6r, if I have a -5 and I subtract 12, -17. And so we have -17 over 6. And if we look back at the beginning of the problem, we have 2 excluded values, one for right there, one for right there. So the 2r in the front, what's the excluded value for the 2r in the front? 0. R cannot equal 0. For the factor in the parentheses, anyone know the excluded value? It's a fraction. -3 over 2. Okay. Is that either of the excluded values? No, so we're good. Our answer is fine. Okay, ready to start practicing? Most of the equations on your assignment today are pretty simple.